Okay, so look like it's 10:02. Now we are going to start our class. Before we go further with today's chapter, it is regarding foundation of movement analysis. I have several announcements to be made. The first one, let's see this one. Okay, so if we take a look at our scheme of work, our lesson plan, we are now at week number 10. Okay, kita dekat sini. Right, this topic we have discussed, so we are quite fast according to plan lah. Now we are week, siapa ni? We are week 10, tapi kita akan, hari ni kita akan masuk topic for week 11. Alright, the thing that I need you to focus on is this one. Nampak kita ada test 1, it will be conducted next week at week 11, and test 1 will be covering chapter 1 until chapter 4. Okay, chapter 1 kita apa? Introduction, and it will cover up until chapter 4. It will be stability of motion. Okay, so determining the center of gravity is going to be the last topic for test 1. But if there are changes, I'm going to let you know later, and it will be conducted next week. Okay, and it is, since it is a test 1, I'm yet to get the question. Most of the time, test 1 will consist of objective and also some subjective question where you need to do calculation or a simple essay. Itu yang pertama. Test 1 next week. So please read up until stability of motion. Okay, and then secondly, I need you to have a look here. Week 13, we have video recorded group presentation and written report to be submitted. So you need to submit your group presentation on week 13, roughly a month from today. Okay, and for group presentation, let's take a look here. Okay, what you need to do is actually a 2D spot skill analysis, which consists of 4 different sections of assignment. Okay, the first section is regarding introduction of the skills. In this topic, you need to introduce the skill that you choose. Example, you choose your sports is soccer, and the skill being chosen is free kick. Okay, so based on that, you need to introduce how to perform free kick, how to execute free kick in this term. You need to talk about movement of the skill, you need to talk about muscles and bone involved in performing the skill, and also joint. You need to talk about mechanical bases, Newton law. You need to talk about anatomical bases, all those plane, sagittal plane, frontal plane, transverse plane, all the movement happen within the plane itself. You need to talk about form of motion, which one is angular, which one is linear. You need to talk about lever and torque. This need to be presented and documented in the first section of your group assignment. And then when you go to the second part of the assignment, you have kinematic and kinetic analysis. And it is recommended for you to use Kinovia to do the analysis. So what kind of analysis you need to have? Part of the analysis will be discussed today in the topic of foundation of movement analysis. Okay, selain daripada itu, you can actually present regarding kinematics, the acceleration, the body part acceleration, both linear and angular, the displacement, the distance, the velocity, all of those things need to be presented in second section of your presentation and writing. And for the third section, based on whatever data that you have presented on B, you need to come up with some step or some ways in order to increase the output of your skill itself. Macam mana kita nak naikkan dia? Talk about impulse momentum theorem. If we increase the impulse here, the momentum will be what? Talks about the summation of force and how we can actually increase the efficiency of the execution itself. And finally, you need to conclude all of those. Okay, special instruction for 2D spot scale analysis. The duration of recorded video presentation will be at least for 15 minutes and at most will be 45. not more than that. Okay, I permit you to do 5% per group max, and then you need to use Kinovia in order to have all those information gathered from the video itself. Okay, so video may be obtained from any available resources such as YouTube, Facebook, TikTok, or even you record the performance on your own. So one of your group members perform and you record pun boleh pakai. Video must have a clear plane of view, and all those recorded video presentation and report need to be submitted by week 13. So for this presentation, it will be conducted via recorded presentation. So you need to record the presentation, upload that recorded presentation in YouTube or whatsoever, and attach the link only in the Google Drive. Okay, Google Classroom. So saya tak nak kamu upload the whole video there. I need you to park that video somewhere. We have issue regarding storage now. So kita tak boleh nak masukkan video yang penuh. You need to upload and attach the link itself. Okay, that is the second one. For this group presentation, I'm going to show you the rubrics. Sekejap And this rubric will tell you about how to present your group report. Okay, these are the rubrics that will be used for group presentation. So in the presentation, you need to have introduction about the objective of your analysis, and then you need to include ni, nombor 2 ni dengan nombor 5 ni, people always forget. Methods of recording, how you obtain the video. Okay, how you obtain the video. Although you take the video from YouTube, you still need to explain about method of recording. Means if let's say you are going to record your own video, what is the setup of the video? How you place the camera? Why it being placed parallel? How many camera do you need? The method of recording. Okay, and then critical observation and analysis. You need to, in order for you to get full mark, you need to analyze, you need to observe at least more than 3. 4 onwards. Okay, 4 onwards. Okay, what does it mean by observation here? Like this. If let's say you take we analyze a curveball cases, case of curveball. So you are going to analyze that. You are going to analyze angle. You are going to analyze velocity. You are going to analyze impulse. All tu baru 3. You need to analyze momentum 4. Okay, so more than 3 observation and analysis of the critical variable, I'm going to give you 4 full marks of that. So kena ada analysis, bukan observe je kita tengok momentum. Mana momentum dia? What kind of momentum? What momentum does? All of that need to be presented. Okay, jadi since the first part of your presentation is regarding the introduction, talk about muscles, talk about joint, dah ada 2 benda dah. Okay, muscles, joint, and then you talk about kinematics, 4 benda. Okay, so meaningful discussion is based on those observation. What can you come out with? Okay, apa benda kamu boleh keluarkan? Momentum macam ni came from this kind of impulse. So if we tweak the impulse, we are going to increase the momentum. Satu benda. Okay, and finally, for every presentation and also writing report, you need to have reference from where you get this information. Jangan pula kat situ nanti Wikipedia atas sampai bawah. No, please use some other sources such as books, okay, such as journals, in order to further enhance your presentation and also report. So I'm going to pin these rubrics in the Google Classroom later, so you can have a look. Alright, that will be the third part for today. Alright, so today we are going to discuss about foundation of movement analysis. In other words, these are some of the examples in terms of point of view from where we can observe performance, from where we can observe movement analysis, kinetic semua tu kan. This is some sort like example. Okay, we can view performance or movement based on this different angle. Okay, all right. So underneath movement, foundation of movement analysis, we have three main approach in order to explain about performance. Okay, in order to explain about performance, we have force mass acceleration approach. This approach is based on Newton's second law. We have impulse momentum approach. This one is still based on Newton's second law. And finally, we have work energy approach. Means we explain things now in terms of work and energy. Berapa banyak tenaga digunakan, berapa banyak kerja yang terhasil, berapa banyak power for each particular athletes and whatsoever lah. Okay, so the first approach and the second approach, I'm not going to touch this in depth since we have discussed this one during mechanical basis of human motion, Newtonian law. Kita dah bincang benda ni secara mendalam. What is the function of F equals to MA? What is the function of I equals to FT, M equals to MV, and what is the theorem interrelated with all of this? Benda ni kita dah belajar. Okay, so this is just some refreshment. We are going to talk in depth towards the last approach, which is regarding work energy approach. Yang ni kita dah tengok. So let's skip through lah. Okay, kalau force mass approach, we talk about force and relation with the acceleration. Jadi bila kita cerita benda yang ini, the major point of view or the type of sport where force mass acceleration approach usually being used is towards sports where time is the essence. Siapa lagi cepat dia menang. Kita gunakan force mass acceleration approach. Okay, and then under principle of impulse momentum ataupun impulse momentum approach, the second approach, we talks about how much force being given, how much movement occur. So how can we manipulate the movement? Macam mana kita nak lajukan dia, macam mana kita nak perlahankan dia. Okay, and all of this approach, force mass acceleration approach, impulse momentum approach, it can be divided into two different what we call it, category or two different domain. One is linear, another one is angular. Maksudnya kita bukan tengok linear je, kita tengok juga in term of angular, both for these approaches. Okay, you still remember all of these things? Ke dah lupa dah ni, impulse momentum semua ni, force mass acceleration. I hope that you still remember all those things lah. Kalau tak, kita cerita benda yang redundant. Okay, we are going to talk a lot regarding work, power, and energy relationship for the first part of this chapter. Okay, so the first one is about work. Okay, is about work. So work is actually how much action, okay, how much force being used in a certain distance to work. Product of a force applied against a resistance and the displacement of the resistance in the direction of the force. So unit for works is joules ataupun Newton meter. Kenapa Newton meter? Because force is in Newton, distance is in meter. So you can either use Nm or you can use joules in order to explain about work. Means here, if the joules is larger, more work is was being done. If the joules is lesser, means less work being done. Okay, for example, is this one. Let's say we have an object. Okay, kita tengok contoh. Okay, let's say we try to push, we have a box, okay, ataupun we have a barbell weight and we try to lift. Okay, we lift a weight. So the question always asks how much work being done by this fella. Tu contoh, we push a box. How much work being done by this fella? So to do so, work equals to force times distance. Okay, F is force, D is distance. Okay, apa force dengan distance? Force is how much force being needed in order to lift this one. Let's see. 1 kg required 2 Newton. So if this one is 200 kg, means the force needed is 400 Newton. Okay. And then distance here is distance of the work being done. Let's say this fella at this height, okay, orang ni pada ketinggian ini dia dah lift up the barbell for 2 meter. So the work done is 400 times 2, which is 800 joules ataupun Newton meter. Okay, and this is where the issue regarding work come, and this is most of the time we solve a problem for weightlifter and also sport, which is quite similar as weightlifter. Okay, let's say we have 2%. We have 2%. Okay, the first person, the height of this one is 1.8 meter. The height of the second person is 1.6 meter. Okay, and these two try to lift up the same barbell, weight at, let's say, 150 kg. Okay, 150 kg. Okay, now how much work being done by A? How much work being done by B? Okay, tengok. Work equals to force times distance. In order to lift up that, we need to know how much force needed first. So 150 kg is mass. Change that into weight. So 150 times 9.81. Berapa dapat kat situ? 150 times 9.81. We have 1471.5. 1471.5 Newton. So these are the amount of force needed in order to lift up the barbell. Kita dah ada F equals to 1471.5 Newton. Now please calculate the work need to be done by A and the work need to be done by B. 5 times with 1.8 work A, and then work B equals to 1471.5 times 1.6. Okay, times 1.8, we have 2649 joules. And another one, 1471.5 times 1.6, we have 2354 joules. So from here, you can notice that the work done is different. Although the objective is quite similar, both need to lift up the barbell up until the highest point. But if your athlete is taller, he actually need to do more work. Okay, berapa banyak beza dia? 2, 3, 5, 4. So the work done is more by 295 joules. Jadi ini antara salah satu sebab why most of the weightlifter after TID we choose a shorter person rather than a taller one. Pasal a taller one need to work more. This is waste of energy. Okay, a taller one need to work more in order to achieve the same objective. Taller to 690 to 650, shorter to 350. Okay, beza dekat 300 joules. Okay, these are some of the problem or some of the analysis that being done if work is the major focus or the outcome of your objective is actually to find out work, power and energy of the action itself. Ni contoh dia, okay? Ada soalan sampai situ? Okay, any question?
Kalau yang individu A tu dia angkat berat yang sama tapi macam tak full tinggi sampai 1.8, dia akan sama orang silakan.
Macam mana? Kalau kata dia angkat rendah lah, dia angkat sampai 1.6 macam tu, sampai sini. Kalau dia angkat sampai 1.6, maksudnya objektif sukan tu tak tercapai lah. Because
tapi work dia sama dengan 1.6 kan?
sama dengan 1.6 lah. Okay, katalah kalau kita nak cari how much height, cuba cari how much height athlete A will have if the work done is equal with to 354. Jawapan dia ni 1.6 lah. Dia takkan dapat angkat penuh kalau energi yang digunakan sama. Okay, if the player use less energy means dia tak akan dapat angkat sepatutnya, which is towards the highest point. Dia akan angkat sama macam ni. So kalau sukan-sukan yang melibatkan work macam ni, it is better to choose a shorter stature of athletes rather than the highest one, rather than the taller one. You are going to save a lot of energy. Okay. Okay kah? Ada soalan lagi? Right. Ni contoh lagi yang kedua dia bagi. A person bench pressing a barbell of 200 Newton, the distance of 1 meter. So the bench press barbell 200, work done 200 Newton meter. But if the person is taller, jadi dia akan bench press more, a bit more rather than 1 meter, mungkin 1.2. So instead of 200 Newton, dia dah jadi 200 something. Work done, the objective is actually similar, bench pressing, but orang A buat lebih, orang B buat kurang, simply because of the height. So in work approach, distance play a major role, which determining whether you are going to do a more mechanical work or less mechanical work. Ni nampak macam ni. Apa ni? Suleymanoglu, shorter in stature. But basically, most of weightlifter we are going to see is short, not because of they have become short since they lift up a lot of weight, but they are chosen. Okay, the short person is being chosen because of the ratio of work being done at the end of the day. Okay. So partner with work is about power. Ni kalau orang sebut, kau power, kau tak power, kau power, kau tak power kan. Okay. Power is actually the rate of work being produced. Jadi kita ada work over time. Okay, ni dia bergalih ni. Okay, power can be defined as this one. Power equals to work over time. Okay, equals to work tadi kita ada apa? Force distance over time. Ni dia work. Okay, this is power. So kalau tadi we have joules, now is joules per second. Okay, ataupun Newton meter per second. Pasal ni Newton meter. Okay, this one is Newton meter or joules, time is in second. So means here, let's compare. Jadi kita ada orang A, orang B. Okay, so orang A is 2649 joules. Okay, work for A is 2649 joules and work for B is 2354. 2, 3, 5, 4 joules. Now let's say both person lift up the barbell within the same stipulated time. Dia angkat barbell ni masa yang dia ambil tu sama, 15 saat. Now let's observe which athlete is much more powerful. So PA is 2649 over 15 and PB is 2354 over 15. Okay, yang pertama berapa kita dapat? Divide by 15, we have 177. Okay, joules per second. And the second one, we have 2354 divide by 15, 159, 156.9, 157. 57 joules per second. Okay, jadi joules per second ni pun kita boleh tulis dalam bentuk wattage watt. Can become 177 watt. 157 watt. So now, although B conducting lesser work in order to reach the same objective, since B and A perform the same objective in the same time as, so A is much more powerful because he do more work within the same time. Ni kalau kamu macam beli mentol lampu kan, ada kat situ 18 watt, ada yang 20 watt, ada yang 26 watt. So, if the wattage is higher, means that particular bulb do more work at the same time compared to bulb yang rating lebih rendah. And that is the reason why the highest rating bulb will give you much clear source of light compared to watt yang rendah. Okay, ataupun kamu pergi kat kedai nak beli mesin apa-apa kan, dia kata okay, mesin ni 200 watt, mesin ni 320 watt, that 320 watt will give you more output simply because it conduct more task at the same time compared to mesin yang watt dia lebih rendah. Contoh, kalau gegel-gegel kan, hair dryer. Okay, hair dryer 240 volt sama je, 120 240 volt. Lepas tu dia mention situ this one is 500 watt. Yang kedua ni murah sikit, this one is 120 watt. So yang 500 watt lagi laju, lagi panas compare to 120 watt. Because kalau 120 watt setiap hours ataupun setiap saat dia buat kerja, contohlah kita assume setiap saat dia buat kerja 120 kali, baik yang 500, setiap saat dia buat kerja 500 kali. 5 kali ganda output compared to the other one. Itu power. Okay, when we talk about power is how much work being done in a period of time. So if more work being done means you are going to be more powerful. If less work being done means you are going to be less powerful. Okay. Katalah kita ambil contoh lagi satu. Now the time taken is different. Okay, we have A 2649 joules. We have B 2354 joules. Okay, now since yang ini tadi tinggi 1.8 and yang ini pendek sikit 1.6, this 1.8 complete the task in let's say 8 seconds, while B complete the task in 7.5 seconds. Kita tengok what is the power of A and what is the power of B. Okay, 2649 over 8, 2354 over 7.5. Okay, 2649 divided by 8, we have 331 watt. And the second one, 2354 divided by 7.5, we have 314. Okay, watt. Although the time taken, the time to execute is lesser, but still it recorded lesser amount of watt compared to A. Maksudnya A ni lagi powerful lah compared to B. Ni cara untuk kita differentiate people or make some analysis by using work and power approach. Belum masuk energy work and power approach. Okay, sampai situ dulu. Ada apa-apa soalan yang menanti? It can be in term of watts, it can be in term of joules per second. Mana-mana boleh pakai. Okay, this one is mechanical power. So, It can be defined as the rate of doing work or the rate of using energy, which are numerically the same. Tengok ni, using energy. Jadi, the rate of using energy is power. Jadi, energy, work kat belakang. Lepas ni kita tengok energy pula. Okay, how we define energy. Alright, if you do 100 joules of work in 1 second, so the power is 100 watts. 100 bagi dengan 1. If you do 100 joules of work in 2 seconds, the power is 50 watts. Because it take longer time. So the lesser the watts, the lesser the power that particular person or that particular machine have or store. Okay, itu ialah mechanical power. Contoh macam ni buat kerja 200 Newton, ambil 2 saat. So the power will be 100 Newton meter per second or joules per second or watt. But if you do the same work in lesser time, you are going to be powerful. The quicker performer has more power compared to the other one. Okay. So training power in an athlete require doing work quickly. So that is the reason why when we talk about power, it is actually strength and speed. Okay, strength and speed. And always when we try to have a powerful athlete, always train their strength first and then speed. Bukan speed dulu baru strength. Okay, train strength dulu and then speed, and then you are going to get a powerful athletes. Okay, itu work and power approach. This one is some of the example measuring power lah. All those things that end up explosive movement is power. It is a form of power. So the much more explosive you are, the much more powerful. Alright. Alright, so let's go to the third part of this approach. Energy. Okay, when we talk about energy, capacity to do the work, you must have energy to accomplish work. So energy is some sort of currency. Okay, to do 100 joules of work, you must expend 100 joules of energy. So energy is, joules is also a form of energy. Jadi joules pun tenaga, joules pun yang sama tadi ialah power. Alright, so when we talk about energy, it can be divided into 3. Kinetic energy, potential energy, thermal energy. Okay, jadi kita tengok energy dulu. Energy. Alright. Let's say we have a person. Okay, we have a person. This person, we can see it store energy. Okay, there are store energy. So, if we have two person, satu besar, satu kecil, we can say that energy store, kita namakan dia ni orang pertama, ni orang kedua lah. Energy store in one is lesser than energy store in two. Since dia kecil, dia besar. Ini konsep dia. Okay, ini konsep dia. So, this concept is known as potential energy. Potential energy. Okay. So, potential energy can be written as PE equals to weight of this object time height of this object. Ini weight weight, bukan mass tau. Maksudnya dia dalam bentuk Newton. Kalau katalah, okay, Mamat ni 80 kg, nampak? Kg, this is, when you see kg, that is mass. So, change that into Newton first times 9.81. Balik dah. 9.18 pula. 9.81. Tu dia. That is how you want to find the energy. Okay. So, contohlah, kita ada satu mamat. Mamat ni, height of this mamat is 1.79. And the weight is 80, the mass is 80 kg. So, how much potential energy we have in this mamat? Okay, 80 times 9.81, we have there 784.8. We time with 1.79. 1405. So, we have potential energy of 1405 joules. Okay, ini konsep potential energy. Belum mamat ni berjalan lagi. Okay, Belum mamat ni berjalan. Okay, if we have these two, katalah these two mamat, the weight is similar lah, 80-80, the mass is similar. Tapi mamat ni 2 meter, mamat ni 1.6. By looking at this, you are going to say mamat ni have more potential energy because he is higher. Okay, so berapa mamat tu punya potential energy? 80 times 9.81. You have 784.8. 784.8. Okay, ini in term of height, weight. Height 2 kali kan, times 2. So the taller person have 1570. Okay, kita ambil genap je lah, 1570 joules of energy. The shorter one 784.4. Sorry. Oh. Saya dah kehilangan kalkulator. Berapa energi mamat yang rendah tu? 784.8 times 1.6. 1256. 1256 joule. Starting without anything, kita dah nampak this mamat, the shorter mamat have lesser amount of potential energy. Itu konsep. Okay. The more weight you have, the higher you are, the more potential energy you are going to have. Okay, let's say kita ada bola. This ball dekat level 3. Okay, this ball dekat level 3. This ball is 500 gram and dekat level 3. If every single level, the height of the level is around katalah kita ambil 10 kaki, 3 meter lah. 3 meter. 3 meter. 3 meter. So we know that 3 meter is 1. Okay, 3 meter. Right. So the height of this ball is 9 meter. And the weight of this ball is, the mass is 0.5 kg. Ni dia punya mass. So berapa weight dia? This is dia punya height. 0.5 kali dengan 9.81. We have 4.9. Okay, equals to 4.905 Newton. So, at level 3, the potential energy you have in the ball, within the ball, is 4.905 times with the height 9 meter. 4.15. Okay, potential energy yang ada dekat sini sekarang is 4.15 joules. And when this ball falls down, the amount of potential energy, within the ball is going to change. Pasal height dia dah berubah. Instead of height 9 meter, now the height is 6 meter. So, the potential energy yang kedua is 4905 times 6. We have what? 4.905 times 6. 29.43. 29.43 joules. And further down, the amount of potential energy will reduce. Okay, kita kira potential energy yang ketiga pula. It will be 4.905 times 3. Okay, tengok baik-baik Sekejap lagi kita ada satu benda yang kamu kena ingat sampai bila-bila. 14.72. 0.72 joules. And then when the ball is at the bottom, means that there are no more height. So PE4 equals to 4.905 times 0. Means the amount of potential energy when you reach the bottom of everything is nothing. None. Ni konsep dia, okay? So potential energy is at the most when you are at the top. Okay. you are at the top. And potential energy is 0 when you are at the bottom. There are no more movement. Okay, soalan saya. If we go, or if a person kick a ball, so the ball is going to travel in terms of projectile. Okay, starting position, ending position, apex. My question, in these three phases, phase 1 at start, phase 2 at the apex, phase 3 at the ending, at which phase the potential energy is at the most? Dekat bahagian mana? Mana? Ni tak yakin ke ni? Ni tak yakin ke ni? Kat mana? S1 ke, A2 ke, E3? Which have the most amount of potential energy? Dekat mana? Kat mana? 1, 2 atau 3? Wih, senyap. Hilang. Where are you? Saya berada di tanah perkuburan Seremban 3. There are no people in here. Where are you?
Ada sir.
Ada, okey. Kamu je ada daripada tadi. Yang lain mana yang lain? Okey, mana satu?
Ada sir, ada sir.
Yeah. Okey. Ada, memang ada. Jawapan dia apa? Which place store or have the most potential energy? Kat mana?
Saya rasa sir.
Mana boleh rasa? Kamu tak boleh rasa. Saya nak tunjuk contoh terang-terang menerang ni. Konsep dia senang. Potential energy equals to weight time height. Potential energy naik, weight naik, height naik. So kalau height dia 0, potential energy dia 0. This one. Apa? So potential energy is at the most where you have the most height. At the apex. Okay, at the apex. Kamu kena ingat ni. Ni kamu kena ingat. Okay, pasal dia ada kaitan dengan yang kedua. Alright. So we hold. Okay, we hold this slide for what? Number 6. We go to the second type of energy, which is known as kinetic energy. Okay. Bila kamu nampak kinetic, sama macam sebelum-sebelum ini, when you see the term kinetic, what come to your mind? Apa benda yang lalu dekat kepala kamu? Kinetic means mojo. Motion. Pergerakan. Kinetic means pergerakan. In other words, when an object or a body is in motion, dia akan ada kinetic energy. Akan ada. But when an object V equals to 0 meter per second, no motion at all, dia tak akan ada kinetic energy because there are no motion. Okay? And why? Why V play a major role? Okay, now let's take a look at the second type of energy. Okay, the first type is potential. The second type is kinetic. Half mv square. Dah terang-terang lagi bersuluh dah. Dia dah bagi tahu kat situ. Kinetic energy is the derivation of half mv square. In other words, you need to have velocity and then only you are going to get kinetic energy. So, benda yang tak bergerak tak akan ada kinetic energy. Benda bergerak akan ada kinetic energy. The more velocity you have, the highest kinetic energy recorded by that particular object or person. The less velocity you have, the lesser amount of kinetic energy you have within that person or within that object. Ni konsep dia. Okay. This is the concept. Tadi konsep yang kita belajar, PE paling maksimum dekat height yang paling maksimum. Okay. Now, we have KE, which have a direct relation with velocity, because kinetic is motion. More motion, more kinetic energy. Less motion, less kinetic energy. Example, we have a ball. We kick the ball travel. Let's say the first ball travel at 2 meter per second. Second person kick another ball, and the ball travel at 10 meter per second. Both of this ball mass is 500 gram or 0.5 kg. Now, what is the kinetic energy you have in ball A? What kinetic energy you have in ball B? Kita kira dulu. KEA equals to half. Mass is 0.5, V is 2 square. KEB equals to half. Mass is 0.5, V is 10 square. So ke 10? Tadi saya sebut 10 ke? 10. Now, what is KEA? 2 square times 0.5 times half. You have 1 joules. KEB, we have 10 square, that will be 100 times 0.5 times 0.5. 25 joules, which conclude by increasing the amount of velocity within the moving object, we are going to increase the amount of kinetic energy within the object itself. Okay, baik. Ni konsep. Okay. So now, kita akan ambil satu contoh saja. Kita ambil bola. Travel in a projectile. Okay. If an object traveling within a projectile, what can you say regarding velocity? Dekat mana velocity maximum? Dekat mana velocity minimum within a projectile? Kita kembali kepada gambar rajah tadi. S1 starting, E pula dah. A, okay, A apex, okay, apex, A2 and ending 3. If we compare these three things, which is max, which is minimum? Yang mana maksimum? Dekat mana kelajuan maksimum bola ni bila kita sepak? Dekat mana kelajuan dia paling minimum bila kita sepak? Mana? Weh, kat mana weh? Sedih lah ni. Kat mana?
Minimum dekat S1 je.
Maksimum dekat mana? Minimum dekat mana?
S1.
S1 minimum.
Starting dia.
Bukan. Kita sepak dia. Point. Dekat mana projectile tak ada velocity? Which part of the projectile you don't have any velocity? Ini kita belajar topik projectile weh. Kinematics and projectile. Setahun dah. Dekat apex. Okay. So minimum dia dekat apex. Because here, velocity kosong. Jadi dekat velocity kosong, dekat sini, KE kosong. Because there are no velocity. So dekat mana velocity maximum? Dekat sini lah. Dekat permulaan. At the instant of impulse being given, that is the point where the velocity is at maximum. Okay, contoh. Kita assume 1 Newton of force being given will make the ball travel at 0.8 meter per second. Okay, now let's see the force being given here is 10 Newton. Okay, the force being given there is 10 Newton. So what is the linear velocity we have here? 10 Newton equals to 80 meter per second. Ni kelajuan asal. Okay, itu pertama. Yang kedua, kamu kena faham, when we use projectile, means we are going to kick the ball within an angle. Within an angle. Okay. So, if the force being given is 10 Newton to the ball, and the angle of attack for this ball, let's say, is 45 degree. First, kita kena tahu dulu 10 Newton ni berapa je tinggal. So, force equals to V sin theta. Okay. Force equals to V sin theta. Ataupun sorry, kita ambil yang mudah dulu. Dia jauh sangat. Okay. In order for us to determine how much force being delivered in term of projectile, force ni kita kena kalikan dengan sin theta. Pasal kita ada angle. So we have 10 Newton sin 45. Berapa force dia? So 10 times 45 sin. Tak edit, salah. 45 sin. Betul itu. Time 10. Point. 7.1. 7.1 Newton. Jadi berapa laju bola? 7.1 kalikan dengan 0.8. 0.8. So the ball travel at 5.7. Okay, so the velocity of the ball is 5.7 meter per second. Okay, ini kita dah dapat kelajuan bola dekat starting. Okay, now let's find out what is the KE of the ball here. Half mv squared equals to half m is 0.5, v is 5.7 squared. So 5.7 squared times 0.5 times 0.5. 8.1225. Okay, kinetic energy dekat sini equals to 8.1225 joules. Kinetic dekat atas ni kosong. Okay. Now, we have two different properties. Kinetic energy, and before this we learn about potential energy. Yeah, potential energy. And we know that when an object is at height, you have potential energy. When an object is in motion, you have kinetic energy. So, in order for us to explain about energy, okay, energy ni, it is actually total energy. Okay, total energy equals to PE plus KE plus TE. But this TE is byproduct. Okay, that TE is byproduct. Contoh, bila kita bergerak, kita akan menghasilkan haba. Sometimes the haba is more, sometimes the haba is less, accordingly to the amount of movement being made. Okay. But this part, okay, part pertama ni, total energy equals to PE plus KE, this one is constant. You can write this as PE plus KE equals to constant. Okay. We are going to talk about this term first. Why it being called constant here? Okay, kalau kamu tengok nota, you're going to have ni, law of conservation of mechanical energy. Kita dah belajar lebih kurang 3 conservation. Conservation of linear momentum, conservation of angular momentum, conservation of mechanical energy. Okay, so based on this mechanical energy conservation, it said that when gravity is the only acting external force, a body mechanical energy remain constant. Okay, what does it means by remain constant? Means any object will have a constant amount of energy being stored within. And this energy being stored within can be divided into either KE or PE. Contoh kan, bola yang kita sepak ni, konsep tu kata, if this object only subjected to gravity, dia punya amount of energy is constant, permanent, tak berubah. Itu je amount of energy yang dia ada. Okay. So, to know how much amount of energy we have within a ball, we are going to to use this equation. PE plus KE equals to C, or it can be further elongated into height times width. This is PE, okay, plus half mv square always equals to a figures. And this figures does not change. Itu maksud dia. Okay, that figures does not change. Okay. Contoh lah, kita ambil bola tadi We take the ball travel. Kita nak tahu berapa banyak energi bola ni ada. Okay. So, let's say the ball, kita ambil kira-kira yang mudah. The mass of the ball is 1 kg. Okay. The mass of the ball is 1 kg. And the maximum height this ball is going to travel is 2 meter. Okay. So, how much energy we have within the ball? Itu kita kena tahu dulu. Okay. So, kita tahu formula dia. Height times width plus half mv square equals to C. Sekarang kita nak tahu berapa banyak C dia ada. So, the most easiest way for you to find out how much C you have is by calculating the amount of force you have at the apex. Kita dah ada semua maklumat dah. Height 2 meter. Weight 1 kg. Lekat 1 kali 9.81. Okay. Kita ambil nombor mudah. 10. 1 times 10. So you have 10 Newton. So the weight here is 10. At the apex, automatically we know that V dia kosong. Jadi kita boleh slash equals to C. So constant amount of energy we have in the system is 20 joules. Meaning, okay, sekarang kita cerita meaning. Meaning, here the ball have 20 joules. If the ball is at the bottom, it also have 20 joules. If the ball here, it also have 20 joules. If the ball in the middle of going down, it will have 20 joules. If the ball in the middle of going up, it will have 20 joules. Regardless. Okay? Regardless. Itu maksud dia. Okay. Jadi, soalan kedua. Okay, soalan kedua. In term of linear, what is the maximum amount of velocity this ball can travel? What is the highest amount of velocity this ball can travel? And we know that the highest amount of velocity that ball can travel is actually at the starting of the projectile. Starting of projectile, kita ada height? Tak ada. So, we use the same equation. Height times width plus half mv square equals to constant 20. So, since it is at the beginning of the projectile, there are no height. We can slash the first part of the equation. So, we are going to have half times 1 v square equals to 20. So, v equals to berapa? 20 bahagi dengan setengah. Okay. Kuasa 2. Berapa dapat? Berapa dapat? 1 kali setengah jadi berapa lah? 0.5. Kerja gila. Kali 1. 0.5 lah. So, 20 bahagi 0.5. And then, the square root, the answer. You have 6.32. 6.32. So, we know that now. The velocity is 6.32 meter per second. Okay. Alright. Sekarang dekat sini. Okay, sekarang dekat sini. Katalah. Okay, katalah. The velocity here is 4 meter per second. Can you find out how high for the second one? Okay. Kita tengok. Dekat sini nanti dia akan reveal satu konsep. Conservation. Okay. Now we try to find out how high the ball at phase 2 if that ball travel at 4 meter per second. Okay, so we have height times weight plus half mv square equals to 20. So height kita tak tahu, times dengan weight dia 10 plus half. Now it is mass. Okay, mass is 1, velocity is 4 square equals to 20. So 10 height setengah, sorry, ni kenapa saya letak V pula, 4 lah. 4 kali 4, 16 setengah kali 16, you are going to get 8 equals to 20. So height equals to 20 minus 8 divided by 10. 20 minus 8, 12 divided by 10, we have, divided by 1 pula. 12 divided by 10, we have 1.2. So, this ball at second phase is only 1.2 meter. Ini principle of energy conservation. Means that in every single phase within the system, that particular object, that particular person have a finite amount of energy. Jumlah dia tu static, it does not change. Jadi apa yang berubah? If you are at the bottom, the velocity change. If you are at the top, the velocity is 0, potential energy tinggi. Jadi kat sini, potential energy maximum. Kinetic energy kosong. At the bottom, kinetic energy maximum. Potential energy kosong. This is what we call conservation of mechanical energy. If one of the party increase, another one decrease in order to stabilize the amount of energy within the system. Okay, katalah dekat sini. Okay, kat sini. So, if this is actually the same level of ball, the same level of height, dia ialah 1.2 meter turun and the velocity is 4. Dia akan sama. Okay, dekat bottom, dia akan sama dengan dekat static. The difference is only towards negativity. Tapi kalau dia tanya amount, the amount is similar. Okay, ini konsep conservation of mechanical energy. Tengok macam ni. Okay, tengok kat sini apa dia bagi tahu. Height 3 meter, potential energy 29.4. Means that kalau soalan dia tanya berapa potential energy an object will have, paling mudah you search for potential energy. Okay, paling mudah you search for potential energy at the apex. Because we know here, in order to find the constant, KE dah tak ada soalan. Because KE is 0. Apex tak ada velocity. Jadi kita boleh cari constant tu dengan lebih mudah. And when you find the constant, every single, all of these phases have the same constant value. Okay? Have the same constant value. And the amount of value, if you add on, you are going to get 29.4. Itulah principle of mechanical energy conservation. Example, okay, kita tengok sini. 29.4 at 2.5. 24.5 times with 4.9 plus 4.9. 29.4. 19.6 plus 9.8. 29.4. 14.7 plus 14.7. 29.4. And finally at the bottom, 9.8 plus 19.6, 29.4. Means that within the system, the amount of energy will be remain constant, tak akan berubah. Itulah konsep dia. Itu konsep energy. Potential energy plus kinetic energy. And the byproduct of that, you're going to have thermal energy. Ni, thermal energy. Okay. So, thermal energy ni kadang-kadang bila kita buat pengiraan work tu, okay, work equals to force time dengan distance, there are some extra amount of joules that is actually thermal energy. Cuma dalam kira-kira buat physics, especially in our area where we work a lot with movement, thermal energy tu kita kurang pandang sangat. We talk about more on kinetic, how much movement occurs based on potential energy of a system itself. Okay, dia lagi kat belakang ni. Macam tak ada lah. Tak ada. Right, now let's take a look some example. Sekejap Okay, let's take a look. An example, what we call it? Friction. Kinetic energy. Okay. Okay, kita tengok soalan berkaitan dengan work, power and energy. Okay. Let's say we have a set of stair. Dah ke belum soalan ni? Pernah jumpa tak? Pernah jumpa soalan begini? Kita ada tangga. Okay. 20 set of stair to be exact. And every single stair, the height of each stair is 20 cm. Okay, ada 20. Ni 1, 2, 3 dan ke atas lah. We have 20. Okay. If a person weak at 700 Newton. Okay, orang seberat 700 Newton. So roughly the mass of this person is 71 kg, something like that. Okay, ataupun kita ambil genap 70 kg lah berat dia. If this person climb all the stair in 1.25 second. Ni dia terbang naik tangga ni. Okay, the question is how much work being done by this person? How much power produced by this person? Okay, and then the final one is how much change in terms of potential energy recorded for this person. 3 benda. First, what is the work done? How much power produced? And finally, the change of potential energy. The change of means that potential energy final minus potential energy initial. Ni M mass. Okay, mass dalam potential energy bukan. Dalam potential energy dia ialah weight. So kamu kena dalam unit Newton. Bila unit kg dia mass. Dia tak ada dia tak ada call it gravitational computation kat situ. So dalam potential energy dia ialah weight time height. So bila nampak weight dia dalam Newton. Bukan kg lagi. So that 700 Newton tu kamu dah selesai masalah untuk potential energy, but for kinetic energy you need to change that 700 to mass dulu. You need to divide that. Ada tak? Dia tak pakai, saya rasa macam tak ada pakai. Tak ada. Dia tak ada pakai kg. So you can just use that 700 Newton. Itu ialah weight untuk PE, alright? Okay, jom kita tengok jawapan ni. Jawapan yang kamu dapat berapa? Berapa work done? How much work being done? Dia pula lah. Berapa banyak work yang kamu dapat? Berapa banyak work kamu dapat? Berapa banyak energy yang kamu dapat? And how much the change of potential energy? Saya nak jawapan dia dulu. Can you give yours first and then kita tengok jalan kerja dia. Berapa work? Work berapa? Hello, hi, Assalamualaikum. Ada orang tak?
Ada sir.
Berapa work?
Saya dapat rendah, sir.
Berapa? Berapa rendah?
2,800 Joule.
Betul tu. Power? 2,800
Power
bagi 1.25.
2,240 watt.
22,440 watt. Okay, and then change of PE?
Change of PE sama dengan PE kan sir sebab kosong.
Berapa dapat?
2,7,468 Joule.
Salah. Saya tulis dulu 274 berapa 6 Berapa
68.
68. Weh, banyak 27468 juga. Okay. Alright. So the first one, work. How 2,800 joules you have here. So work is force time distance. So distance ni kita kena shuttle dulu. 20 ni 0.2 lah. Right? Force is 700. 20 ni 0.2 for every single one kali dengan 20 set. Tu settlekan yang itu dulu. So kamu dapat 400 meter. Sorry. Oh, dia bagi ni. Kamu akan dapat 4 meter. Okay, and then kali 700. Jadi dengan 4. So you have 28,000 joules. Okay, and then for power is work over time. Bahagi dengan 1.25 second. So you have 2,240 watt. And then change of PE ni, maksud dia PE2 minus PE1. Since PE1 at the bottom of the stair, there are no height. PE1 habis. Kita nak PE2 je. Potential energy, height time dengan weight. Weight is in Newton. Dia dah 700. Height dia, height yang paling atas sekali, which is 4 meter. 2,800 joules. Tu dia jawapan dia. Bukan 274 jauh. Besar sangat. Ini besar sangat. Jawapan dia 2,800 joules. Okay. Soalan ni nampak macam...
Saya salah kat gravity sir.
Kenapa kamu masukkan gravity? Kamu kali lagi
sebab
dengan
700 Newton patutnya tak payah answer.
Tak payah. Nampak ni kan bila kita sebut tentang berat orang kan, kalau confuse lah. Dia cerita orang ni lepas tu berat dia 600 Newton. Nampak je Newton ni, ini maksud dia ialah mass times gravity. Maksudnya dia ni dalam bentuk force. Dah ada Newton force tak payah kali gravity dah. Tapi kalau dia bagi tahu the weight or the mass of this fella is 56 kg, nampak kg. So bila kg dia dalam mass. Bila dalam mass dia bukan dalam bentuk force. So in order to change mass to force, kalikan dengan gravity. So nampak kg nak jadi N, kalikan dengan gravity. Nampak N nak jadi kg, bahagikan dengan kg pula lah. Bahagikan dengan gravity divided with gravity. Ni dulu orang banyak confuse ni. Mana satu mass, mana satu weight. When we call it as weight, means it is mass times gravity. Bila nama dia mass, it is in kg. So kg is not in term of force. It is in term of distribution of the mass itself. Ni kalau confuse. But this is quite common confusion lah. Tak ada masalah tu. Lama-lama nanti kamu akan nampak, ni Newton tak payah dah nak jadi G. Ni mass, there are no G inside. So we need to times in order to convert that into Newton. Okay. Let's try this one. We have a ball. That being thrown. Okay, this ball. Okay, ball ni dia dalam 6.5 Newton. Okay, now dalam mass ke dalam kg ni? Dia bagi tahu ball ni is 6.5 Newton ball. So this ball
Mass.
Newton dalam bentuk weight because it is Newton. So kalau mass dia berapa? Berapa mass bola yang 6.5 Newton? It is 6.5 divided by 9.81. Tu mass dia 6.5 bahagi 9.81. So mass dia 0.66 kg. This is mass. This is weight. Newton. Weight. Mass kg. Okay, boleh? Dapat? Right.
Dapat saya dapat.
If this ball being thrown, okay, dia pun dibaling, zas dia baling bola ni. So the initial velocity of this ball is 20 meter per second. Nampak kan? 20 meter per second linear velocity. And this ball being thrown at an angle of 35 degree. So kita tahu ni case projectile. Okay. So the initial velocity of the ball is 20 meter per second and the angle of the ball is 35 degree. Okay. From a height of 1.5 meter. Okay, ada satu benda dia tertinggal di sini. Ya, ada from a height lah. Maksudnya sekarang the relative projection height is +1. Dia bukan selari dengan padang. It being thrown at a height of 1.5 meter. Okay. So the question. Okay. Somebody standing up here try to catch the ball and the height of the catcher is also 1.5. Okay. Nampak benda macam ni maksudnya ketinggian dia sama starting and ending. Okay. The first question is, what is the velocity of the ball if the ball being caught at a height of 1.5 meter? Maksudnya dia nak cari ni. Ni kalau kita namakan V1, dia nak cari V2 at the point of contact. What is the velocity at, kita namakan ni N lah, at E. Okay, that is the first question. What is the ball velocity during instant of catch? And B, if the ball is caught at a height of 1.5 meter, how much mechanical work? Okay, mechanical work being done. Berapa laju bola dekat sini, dan yang kedua, berapa mechanical work being done. So kita tahu work sama dengan FD. Kita tak ada dua-dua benda ni. We don't have force. We don't have distance. Okay. So beside mechanical work being measured like this, we can also measuring work by measuring the change of kinetic energy. The change of, ni salah satu formula lain dia. Okay, means work is also equals to kinetic energy final minus kinetic energy initial. Okay, work is also like that. Okay. Now, let's go to the first one. What is the velocity of the ball if the ball being caught at 1.5 meter? Kat sini. Berapa laju bola dekat sini? At instant of catch. Apa ni? The what we call it? Apa nama orang ni? Apa nama orang yang tangkap bola tu? Catcher.
Apa je?
Berapa jawapan ni? Ini tak payah kira tau. Konsep dia sama macam tadi. Kan kita ada konsep of constant. And we know that at the point of contact and at the point of what we call it? N. Okay, before hit the ground. At these 2 points, it is actually equal. Kalau sini velocity maximum, sini pun velocity maximum. Dekat atas ni, we don't have any velocity. So, if at the starting point, the velocity is 20 meter per second, automatically dekat ending point pun velocity dia ialah 20 meter per second. Itu jawapan dia. The velocity of
Dia
the
sebab
ball.
tinggi sama ke sir?
Ya, sebab dia sama. Gini kan. PE plus KE equals to C. So dekat point of starting, since there are no height, PE dia tak ada. So KE dia lah constant tu, maximum value. So if starting is 20, ending dia pun sebelum orang tu catch, it will be 20. Because it is at the same height. Okay. Semakin menghampiri apex, velocity turun. Semakin menjauhi apex, velocity naik. But the maximum amount of velocity within the ball itself is equals to constant. Dia takkan berubah. Jadi dia bagi tahu dah velocity dia 20. Here at the beginning means dekat starting point 20. So at the ending point, based on this information, it will be 20. Kalau dia tanya dekat tengah-tengah ni, lain lah, you kena cari lah. Okay. If the level is equal, the speed is equal. Okay, boleh? Yang kedua. Okay. Now, we solve the mechanical work being done by using work equals to change of kinetic energy. Okay, so kamu akan ada sebelah lah. Okay, work equals to change of KE, where we have half mv square 2 minus half mv square ni buat kerja 10 jalan ni jadi square 1. Okay. So case
So, velocity untuk KE final dengan initial sama kan?
dekat mana? Dekat soalan 1 ke?
Kat soalan B.
Dekat soalan B. Okay, dekat soalan B ada trick sikit. Alright, so if the ball is caught at a height of 1.5 meter. Okay, if the ball had been caught, maksudnya catcher tu dah tangkap bola. So bila dah tangkap bola, berapa speed dia?
0.
Yes. Soalan pertama tadi, what is the velocity of the ball if the ball being caught at a height? Berapa laju at the instant of catching? No, soalan nombor 2, how much work being done by this catcher? Bila dia dah cakap how much work being done means work had already done. Dia dah tangkap bola. And when that happen, velocity of that is going to be 0. Jadi kita ada satu je velocity kat sini kan? 20. Okay. So, since V2 kosong, so we can actually slash the first part. So, kita hanya tinggal negative half mv. Berapa mass dia tadi? 6.5 Newton. So, 6.5 Newton need to be changed to mass first. You have, saya dah padam lah.
0.66.
0.66. 0.66 and then V is 2 square. Okay, apa kita dapat sini? 20 square times 0.66 times 0.5. 132 joules. Dia ada, kalau ikutkan dia negatif lah dekat sini. But in term of energy, there are no negative energy. So, they just energy. 132 joules. These are the amount of work being done by the catcher. So, untuk kita menentukan ini, kita kena tengok ayat tu betul-betul. Okay, sometimes it is quite tricky if if they give you something like that. Okay. Can we go to another one? Okay. Now is the case of a person. This person is 50 kg. Ni mass ke weight? 50 kg. Is it mass?
Mass. Mass.
Mass. Okay, mass. So berapa weight dia? 50 kali dengan 9.81. Week will be 50 times 9.81. Apa kita dapat tu dulu? 50 times 9.
490.5.
Okay. 490.5 Newton. Ni dia punya week. Okay. If this person perform a maximal vertical jump, dia buat satu vertical jump maximum at with an initial velocity. So, initial velocity dia ialah 2 meter per second. So, the question is, what is the performer maximum KE? A. What is the performer maximum KE? B. What is the performer maximum PE, potential energy? And C. Oh, ada banyak, ada D. C. What is the performer minimum kinetic energy? And finally, how much how much is the performer center of mass elevated during the jump? Senang cerita max height. Senang cerita lah, max height. How much performer center of mass elevated? Kalau kita ambil center of mass orang ni kat sini kan. Ayat ni mengelirukan. Kita ambil center of mass kat sini. Bila dia lompat, so dia akan lompat sampai satu tahap. Dia turun balik center of mass ni. Walaupun kat sini orang dia tinggi lah. Center of mass. So means center of mass here is actually dia nak tahu apex dia berapa tinggi. Right. So first one, what is maximum KE? Dekat mana maximum? Dekat 1 ke, dekat 2 ke, dekat 3? 1 dengan 3 lah kan? At the bottom. Okay. So maximum KE. A. KE equals to half mv square equals to half. Mass is 50. V is 2. 50 times 200 times half. 50. Okay. So maximum KE dia 50. Betul ke salah? Saya salah kira ni. Kan betul? Bu. Ada square.
Square ke?
Ada square. Lupa square. Kau nampak macam 200, half of it is 100. 100 joules. Okay, maximum KE. Maximum PE? B. What is the maximum PE? Saya tak kira dah. Berapa jawapan ni? 100 lah. Buat susah kira. Okay. Maximum PE dia berapa? 100 lah. Logik. Terima tak jawapan saya 100? Kenapa 100? Senang aja. Kenapa 100? Because KE plus PE sama dengan constant. At the bottom, where PE is 0, KE sama dengan C. So, kalau KE dia 100, constant dia 100. So, since constant 100, at the apex, the maximum, okay, maximum potential energy is at the apex. So, now KE plus PE equals to 100. If KE kosong, PE pun equals to 100. That is constant value. PE 100, dah selesai. Okay, C. Minimum KE. Berapa minimum KE dia? Ni pun tak payah kira. Orang gila je kira ni. What is the maximum kinetic energy? Maximum kinetic energy. Minimum kinetic energy occurs at the apex where the velocity is 0. So jawapan dia ialah 0. Okay, finally D. Dia nak tahu maximum height ataupun dia nak tahu apex dia berapa tinggi. Okay, how we want to measure that one? Kita akan pakai bahagian mana? Kita akan pakai equation yang sama. KE plus PE equals to C. So, apex is here and we know that at the apex, velocity kosong. Automatically, KE slash out. So, kita hanya tinggal height times width equals to constant. height, we do know that. Weight dia, apa? Oh, sorry. 490.5. 490.5 equals to 100. So height dia ialah 100 divide by 490.5. 100 divide 490.5, you have 0.2 meter. That is the height achieved ataupun 20 centimeter. Itu cara penggunaan dia lah. And how we use PE plus KE equals to constant K. Okay, boleh. I think we have time for another one. Let's go to another example. Alright, now we have still a ball being tossed. Thus, okay, this ball is 7 Newton. Weight ke mass? 7 Newton. Ada Newton kat sini. This is dia punya
Wait.
weight. Mass dia berapa? 7 bahagi 9.81. You have 0.7 kg. Ni dia punya mass. Okay, if this ball being tossed vertically upward with an initial velocity. So the velocity here is 10 meter per second. The question is, what is the maximum height? So dia nak tahu apex dekat mana. So in order to solve this one, first we need to know constant dia berapa dulu. So PE plus KE equals to constant. Kita nak tahu dia berapa tinggi. Kita ada tinggi dia tak kat sini? I don't think we have the height yet. Okay, kita tak tahu tinggi dia berapa lagi. Jadi kita nak guna yang mana? We are going to use KE. So kita ada V. Okay, height times weight plus half mv square equals to C. So we are going to consult the height at the base. Sorry, we are going to consult the constant based on KE at the base. Jadi, kat base, kita tak ada potential energy. We only have half. M is 0.7 and the velocity is 10 square equals to constant. So, they will be 100. 1, 2, 70. Half of it is 35 joules. Okay, ni constant. And now when we know constant, we have weight, we can find how high based on apex, where constant equals to PE plus KE. At the apex, KE is 0. So constant equals to height time dengan weight dia 7. So height is 35 over 7 and you're going to get 5 meter. That is the maximum height traveled by the ball. Okay. Alright. Any question? Ada soalan-soalan berbangkit? Tak puas hati dengan pengiraan ni. Kenapa dapat macam ni? Any question guys? Ke tak ada soalan?
Tak ada, sir.
Alright. So if you don't have any question, that will serve as the end of our class.